everyone, we're going to find the limit using L'Hopital's rule. We have the limit as x approaches 1 of x squared minus 2x plus 1 to the power of x minus 1. So let's look and see what we have before we get started, which form we have. If you substitute in 1 for your x, you're going to get 1 squared minus 2 times 1 plus 1, and then we're going to have 1 minus 1. So this gives you the form of 0 to the power of 0. So this is the form we have. So therefore, we're going to use L'Hopital's rule and use this format here. So what we want to do is let f of x equal x squared minus 2x plus 1 to the power of x minus 1. Now we're going to take the natural log of both sides of the equation. Bring this power down in front here. All right. And now what we want to do is simplify this real quick. This would be to write it in the form we want. We want it in this form here. We're going to write this as ln of x squared minus 2x plus 1. And we're going to put this in the denominator by writing as 1 divided by x minus 1. Okay, so when you have it this way, we can use L'Hopital's rule. And so we're basically taking the limit as x approaches 1 of ln of f of x. And this is what we're finding. And then when we find this, we'll use this formula. So this is going to equal the limit as x approaches 1 of ln of x squared minus 2x plus 1 divided by 1 minus x minus 1. All right, so we're going to differentiate the numerator and the denominator. So for the numerator, we're using L'Hopital's rule. We're going to get this is 1 divided by x squared minus 2x plus 1 times the derivative of your inner function here, which is 2x minus 2. All right. And then for the denominator, that's just going to be 1, negative 1, minus, or divided by x minus 1 squared. And now let's see what we have by simplifying this. Oh, I should have put the limit here. I always forget that. So the limit as x approaches 1. I get too involved in the problem. Now let's look at this numerator here. We have 2 times x minus 1. And if I factor the denominator, that's going to be x minus 1 times x minus 1. So what happens is these two cancel, and now we're left with, and again, I'm just simplifying this. So let's write the limit here. The limit as x approaches 1, and we're left with 2 divided by x minus 1. And then it's going to be negative, and I'm going to flip this around. So this is going to be times x minus 1 squared divided by 1. Now what happens is these are going to cancel out and just give you x minus 1. So basically when you plug in your 1 for your limit, you're going to get this equals 0. Because you're going to have 2 times 1 minus 1. So this is the limit of ln f of x. 0. So now let's use our formula here, and we know that the limit as x approaches 1 of x squared minus 2x plus 1 to the power of x minus 1 equals the limit of x as x approaches 1 of f of x. What we have is the limit as x approaches 1 of ln of f of x. So the reason this formula comes in handy is we're going to use the limit as x approaches a of e to the power of ln of f of x. Because we want to find f of x, we know that e to the power of ln of f of x equals f of x. So now all we have to do is substitute in our limit of f of x, which was 0. So now this equals and let's just change this to 1 here. We have a 1. So this is going to equal e to the 0 power, because we got 0 for this limit, which equals 1. And that is your final answer. Thank you. Have a nice day. Bye-bye.